While driving down a busy highway, you look up and see a massive jetliner crossing a concrete viaduct directly overhead. For anyone driving into Chicago, this surreal visual is a predictable part of the daily commute. Why would city planners intentionally route 400,000-pound aircraft across a bridge positioned directly above high-speed commuter traffic? The answer lies in Chicago's historic survival strategy. Whenever the city runs out of horizontal space, it simply begins to stack. By the early 20th century, early automobiles had already gridlocked the downtown streets, creating a logistics crisis for the growing city. Adding streetcars to the surface only tightened the bottleneck, forcing engineers to move the city's primary transit lines off the ground entirely. Engineers lifted entire railways into the air to create the elevated loop, allowing trains to pass safely above the active street traffic. When two layers proved insufficient, the city dug downward, constructing over 60 miles of narrow freight tunnels beneath the sidewalks to move goods through a hidden subterranean network. The automobile age eventually forced the roads themselves to become multi-level, resulting in the three distinct tiers of Wacker Drive, dedicated separately to local access, express passage, and heavy freight. Chicago operates on a cardinal rule of urban design. Infrastructure is a series of layered systems that must coexist within the same vertical space. Following the Second World War, Chicago needed to pivot its dominance from railroads to the booming jet age to maintain its status as a national crossroads. The city found its solution in the former Douglas military airfield. This massive wartime production plant provided the existing hangars and long concrete runways necessary to host a global gateway. The subsequent expansion of O'Hare was aggressive, absorbing suburban land and even forcing the relocation of century-old cemeteries to make room for new taxiways. This expansion turned the airport into a massive generator of tax revenue. By acting as a modern checkpoint for national commerce, O'Hare captures value from every person and pallet that passes through its territory. But O'Hare's growth eventually hit a physical wall. New runways were extending directly toward the vital suburban expressways that handle the region's daily traffic. In 1966, planners applied Chicago's vertical velocity to the airfield, designing a taxiway bridge to carry aircraft over the Kennedy Expressway. The structure had to be reinforced for the extreme weight of the era's new wide-body aircraft, including the upcoming Boeing 747. The final design was a composite steel girder bridge, 226 feet long, with a concrete deck engineered to support a loaded jetliner. Beyond static weight, it absorbed kinetic forces of braking thrust and landing gear stress, all traffic flowed uninterrupted underneath. This bridge was the ultimate engineering compromise, allowing an expanding airfield and a major highway to safely occupy the exact same geographic coordinates. That 1960s overpass was not an isolated project. It marked a permanent change in how O'Hare integrated with the city's infrastructure. During the O'Hare modernization program, the airport was entirely rebuilt around a new system of parallel runways. This new layout required additional aircraft bridges, each engineered to carry the largest generation of modern wide-body jets over the surrounding service roads. By treating the airfield and the city as a single stacked system, Chicago fused these two massive networks into a continuous transit machine. Chicago's spatial compromise has since become the standard solution for global airports constrained by urban sprawl. Major hubs from Frankfurt and Heathrow to Hong Kong and Atlanta now rely on airplane bridges to span highways and rail lines. Look up at the skyway and you see a modern jumbo jet slowly creeping over the concrete edge, blocking the sun. That bridge is the architectural evidence of a metropolis that refuses to stop growing. It shows a city built to keep moving,